Hi everyone, it's good to get back to our classes. Today we're gonna be covering chapter 5, utility and game theory. So the chapter starts with a revision of expected value and that we covered in the past, and then through this example we enter the utility approach and we learn what's utility and why it's useful. So here is an example for Swofford company, real estate company. They have three choices to make investment: A, investment; B, or to not invest. And the expected payoff scenarios are here, states of nature. If the price goes up, remains the same, goes down. So the potential payoffs are here. Okay? This is the best case. This is the neutral case. And this one is the worst case. And the probability of occurrence of each state of nature is given here: 30%, 50%, 20%. Okay? So we're gonna be calculating the expected value over here. Expected value is, okay, I created this file in order to have these numbers throughout this lecture in front of us. So the expected value is here. For example, for decision 1, investment A, 30 multiplied by 30%, sorry, 50% multiplied by 20,000 over here, and probability of 20% multiplied by minus 50,000, and the expected value is 9,000. For the second investment B, which we can see it here, expected value is minus 1,000. And to not invest, okay, we don't lose anything, but we don't gain anything. So intuitively, one would say the decision 1, alternative 1, investment A is the best choice to decide because it has the highest expected value. But is that the case? So far we learned that and how we decide about that. But the case is not ending here. There are other things to be considered. For example, okay, we have the expected value here, the highest one associated with the first investment. But the highest potential lose is also associated with this. Okay, what if we are not lucky and 80% is gone away, but to our best chance 20% comes to us? Okay, so there are other factors to be considered over here in order to make a rational decisions. Okay, let's say, okay, so these are the considerations here. Swofford's current financial position is weak. So if this happens here, 20,000 loss, or if 50,000 loss happens, the company can be in danger and the company can go bankrupt if less. Okay, and Therefore, the president of the company may go for the second and third decision in order to avoid this substantial loss over here. And even if they believe that 20,000 loss or 30,000 loss make the company in danger, so they may avoid to invest and go for alternative 3. Okay? So now we turn it to utility. What's utility? It's a measure of the total worth of a particular outcome, reflecting the decision maker's attitude towards a collection of factors. So some of these factors may be profit, loss, and risk. Okay, it's simply the utility is ranking these numbers which are given here in terms of utility, not in terms of dollars. These are dollars. These are monetary values. But these numbers will be ranked in other numbers, like ranging between 0 and 10 for all given possible outcomes over here, payoffs. Okay, so we rank them, and then we find expected value of utility instead of expected value of payoffs in dollars. And then in the same procedure we decide to select the best alternative with the highest utility, expected utility value. Okay? Then how this system works. So there are many steps for this. First of all, we develop payoff table using monetary values as it's given here. Okay? Second, identify the best and worst payoffs and design each utility value with utility of best payoff greater than utility of worst payoff. So in this case, the highest payoff, the best payoff is 50,000 over here, and the worst payoff is minus 50,000. Of course, this is greater than that one, so this applies in this way. So we define the lottery. Okay, the best payoff is obtained with the probability of P, and the worst payoff is obtained with the probability of 1 minus P. Okay, for example, we say that, let me add it here, we may say that, okay, if the probability of occurrence is 0.95, it means the probability of non-occurrence is 1 minus 0.95 and equals 0.055%. So 1 minus P equals 0.05. So this is just an explanation for step 3. So we assign a probability of the best case and worst case. Okay. Now it's applying these stuff, and as we said, utility of monetary payoffs are here. Utility of minus 50,000 is utility, and so we rank them. We rank them, the items over here, in terms of utility. 10 to 0. Define the lottery, and then we define the lottery. The best payoff is 50,000 and probability P, and the payoff of minus $50,000. Step 4. For every other monetary value M in the payoff table, determine the value of P such as that the decision maker is indifferent between a guaranteed payoff of M and the lottery defined in step 3, and then calculate the utility of M. Utility of M equals PU best payoff and 1 minus PU worst payoff. Well, we will have an example and we apply this if you are not getting the idea correctly, so you will be getting that through the examples and problems that we solve. So we establish the utility for payoffs of 30,000. Okay. Now determine the probability value. The probability value, we determine that P is equal to 95%. It means 1 minus P equals to 5%. So these P's will be given in the exam when you face this question. And we have 30,000 over here. So if we assume that 30,000 is 10, okay, then probability of, and the worst case is 0 in each. We said we rank them from 0 to 10. The lowest will be 0 and the highest will be 10. Okay. Anyway, and then the utility of $30,000 is 9.5. So here is 9.5 placed here. The same procedure is applied for all these values and we get these numbers over here. Utility. So we created another table of utility over here instead of monetary value, instead of dollars. Then we go to step 5. Actually that was the step 5. We convert all the payoffs to utility values and then apply the expected utility approach. So expected utility approach we apply and then we rank them. The highest expected value of utility is the best alternative to choose. Here's the table as we have here, and here's the expected value of the utilities. Decision 1 we have 7.35. Decision 2 we have 6.55. Decision 3 we have 7.50. So in this case the highest one is the alternative 3, to not invest. but according to the expected value of payoffs, monetary values, I mean dollars, the best case was this. Okay. So now you may ask, like, why we convert these numbers to utility values, as here. The utility values is telling us like the level of satisfaction of each of these numbers. How much I'm satisfied with this number. How much I'm satisfied with this number. Okay? For example, I'm telling you a simple example and you understand what we are talking about. Okay? So we have two investors. 1, 2. And we have two investments. The same investments. Let's say $20,000 and the same investment, $20,000. Okay? Let's make these in dollar. And we have possible payoffs over here. So best payoff profit is to make 10,000 profit, 10,000 profit. Or worst payoff, or you have two outcomes for this investment. To lose worst, to lose all your $20,000. Okay? Now, the best payoff in utility values. For the investor one, let's say this best payoff gives us 9. But for this one, for the second investor, this gives us 6. Okay? So if you are one investor, most probably the utility approach is the same as payoff approach. It's a monetary values. Okay? But when you have two investors, so what does this mean? It means like within this situation, either to lose all your money or earn $10,000, the investor one is satisfied by, let's say, by 9 points. But investor 2 is not satisfied as investor 1. And he or she gives 6 points for this investment. Level of utility. Okay? What does that tells us? Like this guy, investor 1, is risky. No matter if he loses all his money, he's taking the risk to earn $10,000. And he's satisfied with this investment by a high level. But for this investment, investor 2 is not that much satisfied. And he thinks it's not a good investment. So the level of satisfaction based on the nature of the investors, of the players, okay, in any case, players in any case, is called utility. So now we come back to the utility here. So here is the comparison. In terms of expected utility, the highest one is this one, and the highest expected value is this one, investment A. So you see, the case is not ended here with the expected values. There are other things to be considered. So, as I just explained in this example, there are three types of peoples, players, okay? One of them is risk taker. They are very, very much satisfied with higher risk, but which promised the higher payoff. So that was the risk takers, okay? And also we have risk avoiders, so they don't take risk, okay? If we have here this investment with a potential loss of 50,000, 30,000, 20,000, so risk avoider may go for not to invest, decision 3. But risk taker, when they see this big number over here, so they don't care too much about the risk of loss, and they go for decision number 2. And we have risk neutral, like they have a linear utility, just they are not risky and they are not risk avoider, risk averse, just between them, okay? So if the investor is risk neutral, the best option is to have the best expected value in terms of monetary value, because if we convert this monetary value to the utility value, we get the same result. But in order to make the best decision for a risk taker and risk avoider, so we have to turn these monetary values to utility value over here. Okay, so here's one example, another example over here. So given 3 situation and 3 outcomes, we have 3 decisions over here as well, and probabilities are given here. So decision 1, $100,000, $40,000 in the second state of nature, or minus 60,000, 50, 20, or minus 30,000, 20, 20, or minus 10,000 for decision 3. The probabilities for the 3 states are here. 60% this outcome will occur. 30% this outcome will be obtained, and 10% is the best case. Okay, so let's see how 2 different investors dealing with this situation. Risk neutral decision maker, as we said, they are going to the highest expected value. first expected value in monetary values. Okay, so when we talk about risk neutral, so you go for dollars, not utility. This one is the first investment, the first decision anyway. $14,000 expected value minus loss of $7,000. But here is the positive. So the best alternative, the best decision is D3 for the risk neutral guy. Okay. What about decision makers with different utilities? So we have two other decision makers over here. 100, 94. They rank the utility for the given values over here in this way. Okay. So from now we can understand that this is fairly distributed numbers over here. As we said, the worst case is 0 and the highest case can be 10 or 100 or even 1. In this case we have 100. So it ranges between 0 to 100. But this guy is ranking these utilities in this way. So we see a huge difference. 50,000, the decision maker 1 gives the utility of 94, but the decision maker 2 gives the utility of 58. Okay. So in this one we can understand that he is not satisfied that much up to here, and then this jumps to 100 when 50,000 payoff jumps to 100,000 payoff. So when we see such a jump over here and not regularly distribution of the values over here, so we realize that this guy differs from this guy. One of them is risk taker and one of them is risk avoider. Okay, so if we plot this into a figure we can understand what are they doing. So that's what I meant. Both starts from here and ends up here. Okay. I don't know if I can draw another line over here. Actually, okay, we can do it. Yes. Okay. So this curve is for decision maker 1. Step by step, when the expected monetary value increases, the utility increases as well, and when it goes up to a level, the level of utility gets flat, not more increase. But here at the beginning is flat and suddenly goes up. So this is the curve that representing the risk taker 1, and this is the curve that representing the risk avoider, and this straight line over here represents the risk neutral players, and this graph is very important. So decision maker 1, decision maker has concave utility function. This is concave and this is convex. Okay, and then it is he or she is risk avoider, and the second one, he or she is risk taker. That's why the utility values are important. So given 10,000 profit, for example, can be 6 points of utility for me, but for another guy can be 10 points. So that affects our choices of decision when we are about to decide about to make a decision about anything, investment or promotion or whatever it is. So for decision maker 1, the largest expected value is the third option, the less risky one. Okay, but what about decision maker 2? The most risky one has the highest expected value, so this is the optimal decision for investor decision maker 2. Okay, and here another example, given the same values but the probability is changing over here, so it applies the same approach, and we see that the outcomes may differ based on the probabilities that are given. So you can go over this example and understand much better what it's about. And now we go to the second part of this lecture, which is game theory. So far we were dealing with some alternatives in front of one person. Okay, let me give you another example over here. Game theory. So far, like investor 1 has to decide about this investment. Investor 2 has to decide about this investment. But what about let's say McDonald's and Burger King? What about McDonald's, for example, wants to have kebab in their menu and also pizza. Okay, so they are making market research and they get the outcomes, like how much will be the demand for kebab, how much will be the demand for pizza, and what are the payoffs associated with this, what are the probabilities of success of kebab and pizza for this. Okay, so far we were dealing with this, but now we are dealing with this one. What I mean by this is, what if Burger King also makes kebab? What Burger King also adds pizza to their menu? How this affects the overall expected payoff for this action by McDonald's, and vice versa. Okay, what will happen if both pursue this strategy to have kebab in the menus? What will happen if Burger King adds kebab to the menu and McDonald's adds both kebab and pizza to the menu. What will happen if Burger King adds both in the menu? What's that? Given kebab and pizza for McDonald's. What will happen if Burger King adds the second strategy, which is adding pizza to the menu given this? Okay? So game theory is telling us, finds the solution for this. Okay? So there are assumptions, or some assumptions actually, associated with this game theory. They are telling us that both parties have the same information. Okay? And both parties selects the, let's get back to the slides. Both parties selects the strategy. Sorry, I cannot find the precise. Okay, independently, with knowing that the strategy of the other players. So McDonald's knows the strategy of Burger King, and then establishes the strategy. So both have the same information, and they are knowing the strategies independently. Sorry, without knowing in advance. I'm sorry for that, it's another case, it was in my mind. Without knowing in advance. The combination of the competing strategies provide the value of the game, okay, to the players. We will have examples and you understand what are these. So in this case we have two players in the game, okay, and also the game is a zero-sum game, so it means one of them gains and the other loses. So the gain of the guy, the first one, will be the loss of the other one, and the loss of this one will be the gain of the other one. Okay, and in this case another example can be like a gambling. You pay $10 to enter a gamble, and you have probability 50-50 to win $20. If you win, the other guy loses. If you lose, you are the loser. Okay, so here's one example. Like, suppose that there are only two vehicle dealerships in a small city, and both wants to sell the new cars, and they are establishing strategies for 4 months period. The strategies assumed to be the same for both dealerships, so both are establishing the strategy. Strategy 1 offers cash rebate on a new vehicle. So whoever buys a new car, they will get a cash rebate. Offer 2 is free optional equipment for the car, for the new car. And option 3 is like they can pay on installment with no interest rate on the loan. So both has the 3 strategies. Okay, so dealership B has these strategies, and dealership A has these strategies. So for example, let me go over one of these. Okay, free option strategy, it's A2. The dealership A if they pursue this strategy, they may lose of selling 3 vehicles in a day if dealership B offers cash rebate. But if they offer free option as it is, they can sell 3 vehicles per day. But if they offer zero loan offer, so they lose 1 car per day. What do you mean? They lose the sell of 1 car per day or per week. Okay, so step 1, identify the minimum payoffs of each row, and then the maximum payoffs of each row. So over here for each column. First one, in order to find the best strategy for each player in this game, we find the minimum or the maximum payoffs. First, we find the minimum payoffs of each strategy for dealership A. And then we select the maximum of the minimums, maximum payoff. Okay, let me clearly repeat it. First step we do, we will find the minimum of each row over here, and then the highest minimum, the highest of these. The minimum of this 2, 2, 1 is 1. The minimum of this row A strategy, A2 strategy, is -3, and this strategy A is -2. Now, the highest minimum is 1. Therefore, the best strategy for player A is to go cash rebate. Okay. No matter what the other player is doing, there will be a positive number here. It means they are making a sell. With the minimum 1 sale of a vehicle in a week. What about the second dealership? We will find the highest one over here. Okay, and then we select the minimax. So the maximums and then the minimum of the maximums over here. So the third strategy is the best for player B. Okay? So there are some, for given situations like this, for a matrix table like this, between 2 players, there are some strategies according to the given numbers, payoffs, let's say. There are some strategies to be pursued. Okay, we have one of them which is pure strategy. Okay, let's explain what's pure strategy through the example. The example over here is, we find out that the best strategy for dealership 1 is 1, and the best strategy for dealership B is A, and here is B3. So they are intersecting in this point. This is a saddle point. Okay, so if the minimum of the column maximum equals to the maximum of the minimums, which is it in this case, so we should apply pure strategy. Okay, pure strategy, that's what pure strategy is. If there's a saddle point, or the value of the game is here, if there's a saddle point, intersection point, equilibrium point between the strategy of dealership 1, player 1 and player 2, and if the minimum of the maximums of the columns equals to the maximum of the minimum of the rows, then we should go for pure strategy. Okay, it is given here, so you can review that in your slides and understand what I'm talking about. And then another specification of pure strategy is, or another, the implication of pure strategy is, no player wants to change their strategy because they lose, and this is the best strategy that they can pursue. Okay, the case is the same like for McDonald's and Burger King, like for KFC and Popeyes. They can pursue the same example over here if they want to add a new item to the menu. So that was the pure strategy. But if we don't have this saddle point between them, we cannot apply pure strategy. We have to go to another strategy, which is so-called mixed strategy and dominance strategy, in order to select the best strategy for each player in the game. So yeah, this is the outcome. Okay, so what does this strategy tells us? Like we said, if the maximum value of the player A does not equal to the minimum value for player B, then the pure strategy is not optimal for this game. In this case, we have to go for mixed strategy. Let's have an example and we understand what's about. Now, we have two players here with a strategy A1, A2, and then B1, B2. The strategy, so the maximum ones, the maximum values of the columns are given here, and the minimum values of the column are given here. The highest minimum, maximum, and minimax are not equal. Okay, 8 is not equal to 5. So we cannot say that A2 is the best strategy for player 1, player A, or we cannot say that B2 is the best strategy for player B, because these two are not equal. So what's the solution? What's the best strategy? The best strategy is mixed strategy. So we find the probability of occurrence of each of this. The one with the higher payoff will be the best strategy for each. Okay, now let me have this, if I can in a Word file. Yeah, very good. So, okay. Now, we establish the probability players A selects strategy 1, A1. We find the probabilities whether player 1, player A pursue this strategy given the strategy of B1 by the player B. And then we find the probability of player A pursues this strategy as it is here. Now, so if player B selects B1, the strategy expected value will be 4p plus 11 1 minus p. If we assign p for this, what is remained from this p goes to the other part. If player B selects B2, expected value is 8p plus 5 1 minus p. So we equalize these two and get the best choice as it's given here. 4p plus 11 1 minus p equals 8p plus 5 1 minus p. Okay, so we have 4p here. 11 multiplied by a1 will be 11, and we have minus 11 multiplied by p is 11p. The same is here, and applied over there. So we deduct these negative and positive signs over here. 11 remains 11. 4p and minus 11p remains minus 11p. And then we solve for p. So we get 0.6. And then we understand that 1 minus p is equal 0.40. Now, the strategy A with the probability of 60% and should say strategy A2 with the probability of 40%. So it's a much 60% probability to select this strategy for player A, and 40% for probability for player A to pursue strategy A2. So it's better to pursue A1 actually. 60% strategy probability over here. And what about the player B? Okay, we do the same thing. If player A selects A1, so instead of P we have Q here in order to not mix up the calculation, and we have also the numbers over here. Okay, if player 1 A, sorry, I used to say 1, I don't know why, but when I was taking this course when I was a student, so we used to have our examples in this way, that's why. So we have here A1 So 4q plus 8 1 minus q, and the expected value if the player A pursues this strategy A2 will be 11q plus 5 1 minus q. So we solve for them and we have 0.3. So it's 30% good for this, for player B to pursue this strategy, and 70% to pursue this strategy. Okay, so we put the value of the game, we put the value of P over there. We had 4 plus 4p plus 11 1 minus p equals this and equals 6.8, and for player B is 6.8. So the gain of A will be the loss of B. Okay, it's a zero-sum game. And now we have another strategy to decide which alternative decisions will be the best for each player over here. As we said, like if the game is not pure game strategy, so we go for mixed strategy and dominance strategy. So what's dominance strategy? Dominance strategy is, for example, over here. First of all, we solve the table as we had the row minimums and column maximums. If they are not equal, if they are equal, we pursue the pure strategy. But if they are not equal, then we go for another strategy. Now we understand that pure strategy will not be applied here, and we have 3 by 3 columns and rows over here. It's a kind of, too much. So what in this case, dominated strategy, what we do, we remove one column and we remove one row, and we will have only 4 values over here for the case of simplicity, and then we apply mixed strategy. Okay, here let's say this we have 3 strategies for A1. So one of these strategies is dominated by another one, therefore you can remove it. Okay, what do we mean by dominated? So we have A1 6 5 minus 2, A2 is 1, 1 is smaller than 6, 0 is smaller than 5, but 3 is greater than minus 2. So this strategy is not dominated by that one. Okay, and even not by this one, because this value is greater than this one. But if we can see, A3 strategy is dominated by A1. Why? 6 is greater than 3 5 is greater than 4, minus 2 is greater than minus 3. So we can remove this one. Okay? We can just remove this one. And for the strategies of player B, we can find the same case over here. That's the strategy of B2 is dominated by the strategy of B1. 5 is smaller than 6, 0 is smaller than 1. So we remove this column and we will have only 2 by 2 table over here. And then we apply the same methodology of mixed strategy to get the outcomes. Okay? That was all, and we will solve the problems and you understand better and much better how these are applied and what are the usefulness of them and how possibly will be asked in the exam. I have selected problems for you as usual, so I'll share them with you as a continuous of this tutorial video. Yeah, let's start to solve the problems associated with the chapter, the end chapter problems. So I have selected 5 problems for you. Okay, so you will be studying in these 5. You are expected to command these problems and to know how to solve them. Like, I may ask questions the same format but with different numbers, so you will be able to solve them. Okay, now problem 1 asks, like, there are 3 alternatives, investment alternatives over here in dollars. Okay, thousands of dollars. So investment 1, decision 1, decision 2, decision 3s. These are the payoffs. Okay, when the prices are going up. If the prices stay stable and if the prices goes down. And these are the probabilities associated with each of them. Now the question is asking us, use the expected value approach, which decision is preferred? So we should know that the highest expected value is the preferred decision. So we calculate them as it's given here. These are over here. We calculate them and we get these results over here. And the highest one is the decision 2. Okay, investment 2, B. That's how you calculate. Probability of each of them multiplied by the payoff over here. The value is given. Plus probability of this multiplied by this. Plus probability of this multiplied by this. Then you get the outcome. The highest one is the preferred one, according to the expected values. And just to remind you that this is the best also decision for risk neutral investors. Okay, then let's go for the B part. Is asking us for a lottery having payoffs $100,000 with the probability of P and 0 with the probability of 1 minus p. Two decision makers expressed the following indifference probabilities. So it's not the probability that's given here. It's indifference probabilities, okay? It's a kind which this is the second step for utility approach. Find the most preferred decision for each decision maker using expected utility approach. So the numbers are given here. Okay? And how we solve that one. These are the numbers. And this is also the second part of it. So first of all, this is for decision maker A, okay, and these are decision maker A. So we will find, according to the indifference probabilities for each decision maker here, we will find the expected utility of all three investments, and we choose the highest one. Okay? How we calculate that one? For the expected value of the decision 1, investment A, we calculate it in this way. Given 0.8 out of 100 or out of 10, so here it is assumed that $100,000 equivalent to 10 utility. Okay, this is utility and this is dollar. So we make a benchmark like $75,000 equals to 0.8 from the decision maker A's perspective, which is 0.8 multiplied by 10. It's simply 10, 8. $5,000 is 5, and then $25,000 is 3. Okay, so it's the same for investor B, decision maker B, 3, and let's call this utility 1 and call this utility for B, and that was A, and this is just 1.5. Okay, so instead of the values dollars over here, we multiply these probabilities by these values. Okay, and now that one is okay. So there's a mix over here, some repair in it, and let's check the answer over here. Yeah, exactly. Okay, so here we are, 0.5 multiplied by 10. As we said, the second step is to shift the convert this table from monetary value to utility values. .3 multiplied by 3. See? 0.3 multiplied by 0. So we can add 0 is 0 and 0. And we sum all of them over here. We sum them and we get this. The same for the second investment B. Expected value of decision 1 and expected value of decision 2, and this is expected value of decision 3. Okay, so the highest one is this one for decision maker A. We use the same procedure to calculate the values over here for decision maker B. Okay, decision maker B, and we get this output. So now you see how different it is. For decision maker B, the best project, the best investment is this investment 1. But for decision maker A, the best investment is D3. C. And for the risk neutral guy, the best investment is D2. D2. Okay. C. Why don't decision maker A and B select the same decision alternatives? Because of the riskiness of them. Decision maker A tends to avoid risk. Possible outcomes over here. But decision maker B is a risk taker. Looks for high, as I said before, he looks for this and ignores everything. Like 40% the return on this investment is applicable, is expected. But decision maker 1 wants this investment. Decision maker, like the risky guy, wants this investment. The risk avoider guy wants this investment. The neutral guy wants this investment. So why different? Because of the riskiness of these guys. Okay? So let's check question 3. I could have them in this way, both on my screen simultaneously. Okay. In a certain state lottery, a lottery ticket costs $2. In terms of the decision to purchase or not to purchase the lottery, support the following tables. So you are indifferent to buy a lottery or not. So the lottery costs $2, but if you win, you will win $300,000. So you have two alternatives in front of you. If you either you want to buy this lottery or you don't want to buy this ticket. Okay? So a realistic estimation of the chances of winning is 1 in 250,000. it means 250,000 tickets are already sold. So the chance that you are winning this lottery is 1 out of 250,000. Use the expected value approach to recommend a decision. So we have P, probability of win, probability of loss. The expected value is minus 0.80 if you buy it. If you don't buy it, so it will be 0. So 0 is greater than this, so it's recommended to go for decision 2. So if a particular decision maker assigns indifference probability of 0.000001 to the $0 payoff, would this individual purchase the lottery tickets? What's the expected utility to justify your answer? So we turn this to utility. Okay, now as we said, the highest will be $10 utility, and the lowest will be 0. And probability of not to purchase is actually the not to purchase is this in both cases. So according to the utility, the probability, the expected utility of decision 1 is greater than the expected utility of decision 2. So yeah, if you apply utility approach, you will change your mind and you'll go to buy it. Okay, so let's go for question 5. 3 decision makers have assessed utility for the following decision problem payoff in dollars. Okay, so we have some payoffs, some states of natures, 2 decisions over here, and we have 3 decision makers over here. So they rank the utilities over here. Okay, each monetary value, dollar, is ranked in this way from different perspectives, which reflects the riskiness of these players over here, of these decision makers. So let's plot. The first one is asking us to plot the utility function over here. So when we plot it, we have the probability over here, indifference probabilities actually, or we could have utility here, and then payoffs in dollars over here, monetary values over the horizontal axis. Okay, so we plotted them and we find like A is a concave shape, B is a convex shape utility function, and C is a straight line utility functions. Classify each decision maker as a risk avoider, risk taker, risk neutral. Apparently this is a risk avoider, as we said, concave utility function, and we have here straight line, which reflects for C, investor C, decision maker C, which is neutral, and then we have risk taker over here, jumps from here, B. So A is risk avoider, B is risk taker, C is risk neutral. Okay, Now, for the payoff of 20, what's the premium that the risk avoider will pay to avoid risk? What's the premium that the risk taker will pay to have an opportunity for the high payoff? For the risk avoider, look at here. So we said this is risk taker and this is risk avoider. Now what we can do here, as I said, like how much this guy is satisfied. So it means in order to win $20, how much this guy is paying, or how much this guy is willing to bear risk. That's the case. And how much this guy is willing to bear to win this guy, to win this dollar. So the answer is, we calculate them as it is: 70% of $100, 30% of loss, and it's 40. So 40 minus $20 over here, as it's given in the question, it's $20. So this guy, in order to hope to win $20, he or she is ready to give a premium of $20 risk. Okay? But what about the other one, risk taker one? This guy is willing to pay 30 risk with $30 in order to win $20. So this guy is riskier. Okay? And let's go for problem 11. We have here, consider the following two-person zero-sum game. Identify the pure strategy. What is the value of the game? Okay. I would like to solve it here and get the right answer actually. Now we have player B with three strategies: B1, B2, B3, and we have player A. That's how you answer in the exam, by the way. A1, A2 over here. Now eight, eight, 5, 7, 2, 4, 10. So now we will apply the pure strategy over here. Okay, we find minimums over here. The minimum is 5 here, and the minimum over here is 2. Okay, and we find the maximum of the columns over here: 8, 5, 10. Now the highest minimum is 5. The lowest minimum is maximums is 5. So this indicates for pure strategy. So simply the answer is, for player A, it's best to pursue to take the strategy of A1, and for player B it's the best to take the strategy of B2. And let's check the answer over here, and the value of the game is 5. Okay, question is asking what is the value of the game. The value of the game is 5. Let's go for the last question, question 14. Question 14. I wanna do it in here as well. Actually, okay, just ignore this. We have player B, B1, B2, B3. This is problem 14. And we have here player A, A1, A2, A3. Now, zero, minus 1, 2, 5, 4, minus 3, minus 4, 3, 2. Okay. So since we have 3 by 3, and let's first of all we check minimums over here. Minus 1, minus 3, minus 4. The highest, the maximum is minus 1, and we check maximum of the columns as well. 5, 4, 2, and the lowest one is 2. 2 is not equal to this. If it's equal to that one, it means we have to apply pure strategy, but if it's not, we apply mixed strategy. Actually this is, and since we have 3 by 3, we look for dominant strategy, and let's see which one is dominated by which one. So obviously this one, this column. Okay, let's first try the A players strategies. So this one is dominated by that one, so we remove that one. Okay, now this one is removed by that one. This one is minus 1 is smaller than 0, 4 is smaller than 5, so this B2 is dominated by B1. So I will delete that one as well, and these, let them go, and let them. Okay, so we are here with this one. Let's check the answer in case. No, I'm sorry. We should have that one. I'm sorry for that. because I didn't check the answers. I have already the answers, but I wanted to go step by step with you. Now the optimal answer is here. It means, okay, we were correct to removing this one, but actually it's almost the same. So strategy A3 is dominated by A2, and strategy B1 is dominated by B2. Am I doing some mistakes over here? B1 is not dominated by B2. Actually, B2 is dominated by B1. Anyway, you sorry guys for this confusion. Actually, the dominance of the strategies of B player is wrongly stated over here. Okay, but you assume that you will be remain with this table. Okay, 2x2 game. Okay, just assume this one is correct and follow the steps. I just checked the answers and the steps are over here. I don't want to extend on you. That's why I'm just giving you the answer. Try it to get the same results. If you have a problem, if you don't understand anything, just let me know during the normal online sessions. Ask me the questions, whatever it's you feel it's difficult for you or you don't understand. All are important, these questions. Very much important, very much useful in your life. Yep. Thanks for everything. Thanks for paying attention and have a nice time.